Okay, we're going to look at graphing linear equations. And the method we're going to look at first is the table of values. All right, so here's my linear equation. Here's my table of values. Now you can choose anything you want to put in the x row. I'm going to choose 0, 1, 2. You might choose 1, 2, 3 or 4, 5, 6. It doesn't really matter as long as it fits onto your number plane over here. All right, now to find the y values which go with the x values, we have to substitute each x value into this equation. Okay, so we are going to sub into y equals 3x plus 2. Okay, so let's start with x equals 0. So I'm going to put x equals 0 into this equation. So it's going to give you y equals 3 times 0 plus 2, which equals 2. Because 3 times 0 is 0 plus 2 is 2. So 2 is my first one. Then I'm going to put x equals 1 into the equation. It's going to give you y equals 3 times 1 plus 2 equals 5. Right, 3 1s are 3 plus 2 is 5, so there's my second point. X equals 2, and then I'm going to get y equals 3 times 2 plus 2, which is equal to 8. Okay, so I've got 3 points I'm going to plot. 0, 2 is my first point, then 1, 5 is my second point, and then 2, 8 is my third point. So let's do that over here. 0, 2, 1, 5, and then 2, 8. There it is. Now you're going to get your ruler and draw a line through those points. Now don't do this. Don't just join the dots. Okay. What you've actually got to do is extend the line so it cuts the y-axis and the x-axis. And you should show the line extends past the points that you've plotted. Okay. Make sure you put arrows on the end to show that the line goes forever in both directions. So arrow there, arrow there. Y equals 3x plus 2. And you should label the equation. Okay. Let's look at the next one. Now again, you can choose any numbers you like for the x row. So you could do 5, 6, 7. Trouble is I don't have a 7 on my x-axis. I only go up to 5 here. And the easiest numbers to choose are 0, 1, 2. Okay. So we're going to sub into this equation. Here's my new equation, y equals 2x minus 1. So sub into y equals 2x minus 1. So we're going to replace the x there with each one of these values one at a time. So we'll start with x equals 0. Okay. And I'm going to replace the x just here with 0. Now that works out to be negative 2 times 0. 0 take 1 is minus 1. So that's my first y value. I'm going to put an x equals 1. So that becomes negative 2 times 1 minus 1. Put that into your calculator. That's going to give you negative 3. And then x equals 2. That's going to be negative 2 times 2 take 1 equals negative 5. Okay, and just remember that those values you're subbing in, so here are my 3 values from the table. So 0, 1 and 2, those are the x values I've put into the equation, okay, to get the matching y values. Okay, so let's plot those points. 0, negative 1 is the first one, so that's just here. Then 1, negative 3 is my next point. Then 2, negative 5 is my point after that. Just there. Now, get your ruler. And again, let me just mention, don't just join the dots. So there's me joining the dots. Don't do that. You've got to extend the line past the points that you've plotted. Okay, past, and it should cut the x and the y-axis. All right. So once you've done that, arrows on the end of the line to show that it goes forever in both directions. And typically you will label the line with the equation. So y equals negative 2x minus 1. Okay. Now, let's do a harder one. Now, here you can see the equation is a little bit harder. So we have to do some algebra for this one. So we'll start off with 0, 1, 2 again. Now, let's start off with x equals 0. So I'm going to put x equals 0 into this equation here. So it's going to be 2 times 0 minus 3y equals 6. 2 times 0 is 0, so I've just got minus 3y equals 6, and then divide both sides by negative 3. That cancels. Y equals negative 2. So that's my first point. Now, let's try x equals 1. Okay, so x equals 1 will have the same working out, except this time the 0 is replaced with the 1 there. So 2 times 1 minus 3y equals 6. It gives me 2 minus 3y equals 6. And then take 2 from both sides. Gives you minus 3y equals 4. And then divide by negative 3. Cancel, cancel. You get y equals 4 over negative 3, which is just negative 1 and a third. Okay, so go back to your table. Negative 1 and a third. Now you can see these are fractions, they're not working out so nice. Last point, x equals 2. Let's put that into the equation. So you're going to get 2 times 2 minus 3y equals 6. 4 minus 3y equals 6. And then minus 4 from both sides. It's going to give you negative 3y is equal to 2. And then divide by negative 3. And you're going to, that cancels there. You're going to get y equals 2 over negative 3. Or negative 2/3 if you like. Same thing. So, you notice that these aren't nice whole numbers. And it means that we're going to have to go up by thirds. Okay? So every 3 dashes is going to be 1. Every 3 dashes is going to be 1 unit. And that's because each dash is 1/3. Okay, so 1/3 there, negative 1/3 there, negative 2/3, and then negative 1, and then all the way down to negative 2. Nope, missed that one. Yep. So every 3 dashes is 1 unit. So we're going up by thirds. 1, 2, 3. So negative 2 down there. Now, look at the x values. They're just going up by ones. So I'm just going to go 1, 2, 3 there. And negative 1. Now, as long as the spaces are going up by the same quantity on the axes, you can use a different scale for the x and y axis. Okay, so now we've got our points. Let's plot them. So 0, negative 2 is down here, all the way down here. 1 and negative 1 and a third. And negative 1 and a third will be just here, won't it? Negative 1 and 1/3. So 1 and negative 1 and a third is just there. And 2 and negative 2/3 is just there. So you get your ruler out, and now again, I'm emphasizing, don't do this, right? You must extend that line so it cuts the x-axis and the y-axis. Cuts means it goes past, and draw it past those plotted points there. You can see I didn't draw that point so well. I missed it a little bit. All right, so there we go. There we go. And this point here should have been, well, the line should have gone right through there. All right, so that's my equation of my line. So, which was 2x minus 3y equals 6. Okay, so what if you don't like fractions and you want to avoid that? Well, we could do that. So let's do the same question again. All right, so if you want to draw your line 2x minus 3y equals 6, now we know that 0 and negative 2 is the first bit, and we know what 1 and 2 are already. You could extend your table and keep adding values until you get a nice little whole number, okay? So we know that this was negative 1 1/3, and I think, what was the other one? Negative 2/3. Okay, so negative 2/3. So if I extend it, let's just add a value here, you might get lucky. So now I'm going to sub in x equals 3 into the equation. So it's going to give me 2 times 3 minus 3y equals 6. It gives me 6 minus 3y equals 6. Minus 6 both sides. You get minus 3y equals 0. And then divide by negative 3. And you get y equals 0. So that's actually useful there, because it means that I'm not going to plot all the points, by the way. Here I only need 2 points to really plot to draw the line. So I'm going to do 0, negative 2, and the other one is 3, 0, which is here. So I've just extended the table until I've got some nice whole numbers for the y values, and then I can just draw my line. Right, so as I said, don't do that. You've got to extend through both those points. Okay, put arrows on the line. Right, there we go. So if you're getting these fraction values, you keep adding columns to the table until you get nice whole numbers. That's one way of doing it. And you don't have to plot all the points. You can just plot 2 if you want. So I plotted this point and I plotted this point, right? I only need 2 points as a minimum to draw a straight line. So now if you're saying that the lines don't look the same, well, that's because I use a different scale. Okay, the scale on the y-axis here is going up by thirds, and the scale here is going up by ones, all right, for the y-axis. So that's why they look different, but they're still graphing the same equation. The last one, this one here. So we're going to do a little table of values. X, Y, 0, 1, 2. Now, if I put x equals 0 in there, I get 1. You can do the arithmetic for this. If x equals 1, I'm going to get 1 3/4. And if I put x equals 2 in there, I'm going to get 1 6/4, which is 1 6/4. That's going to give you, as a simplified fraction, 1 3.5. So that's 2.5 there. Okay. All right. Now, could go up by halves actually. That'll do. If you just want to stick to whole numbers, what I would do is choose a x value which is the same value as the denominator, because that'll cancel the denominator. So if I choose a 4 here, put in 4, you're going to get 3/4 times 4 is 3 plus 1 is 4. So I've got 0, 1, and then 4, 4 that I can plot. Okay, so if I put the numbers on the axis here, 1, 2, 3, 4, and then 1, 2, 3, 4. Let's plot those points there. So 0, 1 is here, and then 4, 4 is here. Okay, so that's going to give you an easy line to draw now. So let's just draw that through. So here are the 2 points. I don't need to plot any more than 2 points. Third point is usually just for more accuracy. So just drawing that through, extending it past those points. And there it is. So there's my equation, graphed as a straight line. Okay, so that is my last example. If you wanted to, on that scale, you could have done a different scale if you wanted to. You could have gone up by halves or quarters on your y-axis. It's up to you, but it's easier, I guess, in this case, just to use the whole numbers. And you only need 2 points, 1 and 2, to draw the straight line. That's it.